So we are beginning with alternating current. तो सवाल बहुत सारा आता है कि इसका क्या जरूरत है। जब एक आपने ऑलरेडी एक डीसी करंट बनाया हुआ है, so why there is a need of an alternating current, what it is going to do which DC current was not capable of doing, एक्सेट्रा एक्सेट्रा एक्सेट्रा, उससे रिलेटेड काफी सारा और बात। तो वी बिगिन फ्रॉम दिस पर्टिकुलर एस्पेक्ट। तो अपने उसको समझने के लिए सबसे पहले तो एक एसी जनरेटर को पहले पढ़ना है। तो एसी जनरेटर का कंस्ट्रक्शन अगर अपने देखें तो देयर इज north and south pole of a magnet. To create a magnetic field in this region, and we will consider that the strength of magnetic field is equal to B. The strength of magnetic field will be considered to be B, and armature will be rotated inside this region of magnetic field in this way with the help of a external agent. तो यहाँ पे आर्मेचर को जो है वो रोटेट कराने के लिए किसी एक पर्टिकुलर एजेंट का इस्तेमाल किया जाता है। अब जैसे अगर हाइड्रो इलेक्ट्रिक प्लांट का बात करें तो वहाँ पे बहुत जोर से पानी को गिरवाया जाता है, तो जब वाटर फ्लो की वजह से दिस आर्मेचर कॉइल रोटेट देन इलेक्ट्रिसिटी इज जनरेटेड। इन केस ऑफ स्टीम पावर प्लांट, maybe coal or something else is heated to produce a large amount of steam, and then steam is pumped on this blades of the armature coil which ultimately rotates this armature. तो ये कुछ इस तरीके का अरेंजमेंट है। Ultimate idea is to rotate this armature coil. Now inside this we have slip rings arrangement. इसको अपने नाम देते हैं slip rings। ये इसके थ्रू आ रहा है, ये एक और slip rings, and then it is connected with a carbon brushes. It is connected with a carbon brushes, and in turn it is connected to the external circuit. Finally एक external circuit में जाकर के इसको अपने connect करें। So now our idea for the preparation of alternating current is restricted to this particular network of armature coil, जिसके एक रोटेशन के वजह से एक मैग्नेटिक फील्ड क्रिएट हो रहा है। So the strength of magnetic field is taken as B, and we are representing it in the form of a B vector. अगर अपने डायरेक्शन ऑफ करंट के ऊपर अगर अपने चर्चा अगर करें तो डायरेक्शन ऑफ करंट विल बी डिटरमाइंड यूजिंग फ्लेमिंग्स लेफ्ट हैंड रूल। तो अपने कुछ यहाँ पे इस तरीके का बात करते हैं कि ये वाला जो आर्मेचर कॉइल है, ये इसका मोशन ऑफ, इसका टेंडेंसी ऑफ मोशन इज डाउनवर्ड्स। जैसे इफ आई नेम दिस एज PQRS, so the tendency of motion of PQ is in the downward direction and the tendency of motion of RS is in the upward direction. तो अगर ये डाउनवर्ड डायरेक्शन में अगर है और वो अपवर्ड डायरेक्शन में अगर है, तो बेस्ड ऑन दिस वी कैन फाइंड आउट द डायरेक्शन ऑफ करंट बाय अप्लाइंग फ्लेमिंग्स राइट हैंड रूल। तो फ्लेमिंग्स राइट हैंड रूल अगर अपने इस्तेमाल अगर कर रहे हैं तो द मैग्नेटिक फील्ड इज रनिंग फ्रॉम नॉर्थ टू साउथ, द टेंडेंसी ऑफ मोशन इज अपवर्ड एंड द करंट इज गोइंग इन दिस डायरेक्शन। तो करंट का जो डायरेक्शन है वो इस पर्टिकुलर लूप में इस तरीके से एस्टैब्लिश कर लिया जाता है। तो एक एक करके अगर अपने समझें तो अगर अपने PQ वाले ब्लेड को अगर देखें तो PQ वाले एंड में टेंडेंसी ऑफ मोशन इज डाउनवर्ड, मैग्नेटिक फील्ड इज टुवर्ड्स द राइट, तो यू आर यूजिंग राइट हैंड रूल। तो अपने राइट हैंड को इस तरीके से अलाइन करिए कि योर इंडेक्स फिंगर इज पॉइंटिंग इन द डायरेक्शन ऑफ मैग्नेटिक फील्ड, यानी कि आप मानिए कि जो जो येलो वाला लाइन है उसके तरफ, योर थंब इज पॉइंटिंग इनटू द प्लेन ऑफ द स्क्रीन, so your middle finger will be pointing from Q to P, which is the direction of current. Similarly, RS वाले ब्लेड के लिए अगर आप देखें तो the magnetic field is pointing towards the right. तो राइट हैंड रूल अगर अपने इस्तेमाल कर रहे हैं तो तुम्हारा फिर से इंडेक्स फिंगर इज फ्रॉम इन द येलो डायरेक्शन, the tendency of motion is upward, so this time your thumb is pointing outside the plane of the screen, and then your middle finger is pointing from S to R. तो अपने ऐसा बोलेंगे कि भाई यहाँ पे एक इस तरीके से करंट इज established. If I take that the rotation is taking place with an angular frequency omega, frequency f है और ओमेगा को अपने लिख दे रहे हैं 2 pi f, which is angular frequency. तो अपने यहाँ पे कुछ कुछ बात अगर लिखना स्टार्ट अगर करें तो यहाँ पे मैं सबसे पहले लिखता हूँ that the value of flux is written as B dot A. So if I write it in terms of the dot product technique, then it can, and for n turns, so we will write it as NBA cos theta. Now theta is equated to omega t. Theta is equated to omega t, and hence we can write that the flux at any instant of time can be written as NBA cos omega t. अब अगर अपने EMF इंड्यूस का बात अगर अपने करें तो EMF इंड्यूस्ड इज कैलकुलेटेड एज माइनस ऑफ डी फाई बाई डी टी, और माइनस ऑफ डी फाई बाई डी टी अगर अपने करें तो वी विल राइट ओवर हियर माइनस एन बी ए, कॉस का डेरिवेटिव आएगा माइनस साइन ओमेगा टी, and the value of EMF induced can be written as NBA omega sin omega t. ये वाला जो टर्म है हमारे पास NBA omega, this is written as E naught. This is written as E naught. तो अपने लिख देते हैं E as a function of time is equal to E naught sin omega t is an example of alternating voltage. So this is an example of a alternating voltage, and if I write a current in terms of EMF, then I will write it as E naught by R, which I am writing as I naught sin omega t, and there is a phi, which is a phase difference between the current and EMF, and this is regarded as the expression for alternating current. तो ये हो गया एक कंप्लीट डिस्क्रिप्शन कि किस तरीके से हम लोग एसी करंट को बनाए, किस तरीके से अपने एसी करंट को डेवलप किए, एंड हाउ वी हैव कैलकुलेटेड इट ओवर हियर. नाउ फ्यू फैक्ट्स आर टू बी स्टेटेड. तो जो कुछ फैक्ट अपने अगर स्टेट अगर करें, so the first fact that we are going to state over here is the frequency of alternating current in India is 50 hertz. So omega, which is equal to 2 pi f, will automatically be written as 100 pi radian per second. And if I write the expression for I, then it will be written as I is equal to I naught sine of 100 pi t plus 5. But as per numerical requirement, the equation can be changed. The few things which is to be established is I is equal to current as a function of time, and gives us the value of instantaneous current, gives us the value of instantaneous current at a time t, I naught is regarded as the peak value of current, or the maximum value of current. The entire term, when I write I is equal to I naught sine omega t plus phi, so this entire term inside this bracket is regarded as phase, and the phi over here depict phase difference, and it is generally phase difference with alternating voltage, So this is the complete understanding of this particular equation, which we write as I is equal to I naught sine omega t plus phi. You can also write it in terms of cos. Maybe you can write it in terms of I is equal to I naught cos omega t plus phi. So if we come back to this previous page, so over here we have first of all discussed about the creation or generation of AC current, and followed by this we have come to this part where we have discussed about the equation of AC, and the important point that is established is that the alternating frequency in India is 50 Hertz. The next thing that we are going to discuss is how we are going to represent current. So we are coming to this part where we are saying representation of current. What do I mean to say when I say representation of current? There are two representation which will be helpful for us to understand the complete working of AC circuits. The first one is time varying representation, in which we are representing current and voltage as a function of time in the form of a sine graph. So this one we are marking as graphical representation. So if I take EMF with time, alternating EMF with time, so we are considering at t equal to 0, EMF is 0. That is, we are considering no phase difference between EMF and current. So the current is also obtained in the same way. So it is completely in phase. Completely in phase means when the value of EMF is at peak, so is the value of current. It is completely in phase with the value of current. So we have these two equations where we have written EMF as a function of time and current as a function of time. The peak of the graph over here is marked as E naught, where we write E naught is equal to NBA omega, and the peak of the graph over here is I naught, where I naught is marked as E by R or E by Z. अपने इसके ऊपर बात करेंगे why it is E by Z or E by R. तो ये हो गया एक graphical representation where we have taken phi as 0. There is no phase difference between EMF and current. The next representation that we discuss is called as phasor representation. It will be much more useful in comparison to the graphical representation. So in the phasor representation, we will be representing current like this. So if I draw something like this, so we are considering over here that EMF is represented by this particular vector E naught, where the length of the vector is equal to the peak value of EMF. So everything over here is represented as an anti-clockwise rotating vector, and the current we are representing is in this way. We are representing current as an anti-clockwise rotating vector. So we are taking current at an angle phi. So this time we are representing as if the current is making a phase difference of phi with EMF, and again the length of this rotating vector is I naught, which is rotating with omega. So we represent it as an anti-clockwise rotating vector. So if I represent it as an anti-clockwise rotating vector, then we will have two components of current as well. This is I naught cos phi, and the other one is I naught sin phi. We will be discussing about them, what they are representing. Right now I am just mentioning what it is. It is regarded as wattless current. I naught sin phi is regarded as wattless current. So this is the phasor representation of current, in which we have represented EMF and current along with each other, having a phase difference of phi. So we are discussing two different types of current: average current and RMS current. Two types of current. So the first one that we are discussing is average current. So as we have seen that current is continuously fluctuating with time. If the current is continuously fluctuating with time, then there is a necessity that we find out the average value of current. So if we calculate the average value of current, then the formula for the I average can be written as integration of I dt. So current as a function of time into dt from a time span t1 to t2 over which the average is being asked, upon integration dt from t1 to t2. So over here we are calculating two average current. So if we are considering that the alternating current is given as I is equal to I naught sin omega t. So we are calculating average value for half cycle and for the full cycle of the alternating current. So first of all we are calculating for half cycle. So when I say half cycle, we are taking time frame from t1 equal to 0 to t2 equal to pi by omega. So if I frame the equation, then I will write it as I average is equal to I naught sin omega t dt, and the integration is done from 0 to pi by omega upon integration dt, and again the integration is done from 0 to pi by omega. So if we solve this, this is a very basic integration. We obtain I naught. Integration of sine is written as minus cos omega t, and then we divide by omega, and over here dt will come out to be pi by omega. We put the upper limit minus lower limit. It will turn out to be pi by omega, so we can cancel omega. And on solving, we obtain I average is turning out to be 2 I naught by pi. So for half cycle, the average value of current is coming out to be 2 I naught by pi. The next which we are doing is we are calculating for full cycle. The only thing that is going to change in the calculation of full cycle is the limit. So I am changing it over here itself. So the half I am making it as a full cycle. And then the change in limit is to be done. So we have to change limit on the upper and lower side both. So I'm clearing this out. So we will attain something like this from 0 to 2 pi by omega. From 0 to 2 pi by omega. T2 is equal to 2 pi by omega. So this time we are getting I naught, and integration of sine omega t is minus cos omega t divided by omega into 2 pi by omega from 0 to 2 pi by omega. And we can clear it out. So we obtain this time I average is turning out to be I naught by 2 pi, and the value of cos omega t in this zone is 0. So the I average is equal to 0. Graphically, we have already seen that if we look at this full cycle of the current, so we can clearly see over here that in this full cycle, the value of current is in the positive half cycle in this part, and in the negative half cycle in the other part of the cycle. So the value is bound to be 0. So there is a positive value that is created in the first half of the cycle, and then the negative value is created in the other half of the cycle. So the average value of current is going to turn out to be 0. And I can make a note over here that the average value of current over a long interval of time, average value of current over a long interval of time will be 0. So the average value of current over a long interval of time is turning out to be 0. So the next one which we are going to study is regarded as RMS current, and is the most useful one which we use most often. And in the question, whenever it is saying that AC circuit is there in which the current is flowing, so that current is considered to be equal to RMS current. So we are discussing RMS value of current. So the first thing that we are going to do is we are going to give a mathematical definition for this value of current. So before that, I am giving you logic behind RMS current. It is also regarded as a DC equivalent current for an AC circuit. When I say DC equivalent current, I mean to say that this value of current will give the same amount of energy spent in the circuit if the DC equivalent of that value is flown through the same circuit for the same interval of time. So if we consider something like this, that there is a DC circuit in which a resistance R is there and I current is flowing through this. So the power is written as I square R, and the value of energy that is spent in this circuit is equal to I square R dt. Now in case of a AC circuit, when the current is continuously fluctuating with time, we consider that I RMS will give us the same amount of heat energy generation. So we write it as I RMS square R dt. So this time if I equate the two terms, then I can write that I RMS square R dt can be written as I as a function of R dt, where I RMS square can be written as I as a function of t square dt upon integration of dt from a time interval t1 to t2 and t1 to t2 respectively. So this is the logic behind calculation or defining RMS value of current. So the RMS value of current will always be utilized whenever we are going to do power calculation in the circuit. Whenever we are going to discuss about the thermal energy that is developed in the circuit, we are going to discuss about the RMS value of current. So if we consider, we calculate the RMS value of current for the half cycle. So using the same equation of current, that is I is equal to I naught sine omega t, and we are calculating between the time interval t1 equal to 0 to t2 equal to pi by omega. So I RMS square is going to be written as I as a function of t squared dt from 0 to pi by omega upon integration of dt from 0 to pi by omega. So if we consider to solve this integration, so over here we are left with this particular expression I naught square integration of sine square omega t dt from 0 to pi by omega upon integration of dt, which is written as pi by omega. So we are writing over here from the formula of cos 2 theta, which is equal to cos square theta minus sine square theta. So we can write it as that cos 2 theta is equal to 1 minus 2 times of sine square theta. And from here I can say that sine square theta can be written as 1 minus cos 2 theta by 2. So if we do this substitution over here, so this expression is modified to I RMS square is equal to omega I naught square by pi integration from 0 to pi by omega half dt minus of cos 2 omega t dt from 0 to pi by omega. So this is how the expression is going to be changed on substituting this value. The cos part of this integration is giving us 0 value. So the value that we are left with is I RMS square is equal to I naught square omega by pi into half pi by omega. And the RMS value of current is turning out to be I naught by root 2. If you solve for the full cycle also, then the RMS value remains the same. So for full cycle also, the value of I RMS is going to remain unchanged. That is, it will still turn out to be I naught by root 2. So we are keeping it till here in this particular session.